it. Object-oriented programming, or OOP for short. We're going to get into the 4 foundational pillars that make it such a smart and honestly elegant way to build things with code. So, to really get why OOP is such a big deal, we first need to talk about the problem it was invented to solve. And that problem has a name that's both hilarious and absolutely terrifying to any developer: spaghetti code. And what is that? Well, just picture it. A program where all the different functions are just tangled together, like a big old plate of spaghetti. You try to pull on one noodle, change one little thing, and the whole plate moves. It creates a chain reaction that breaks a bunch of other stuff you didn't even touch. It's fragile, it's a mess, and it becomes a total nightmare to work with as a project gets bigger. So how did we end up with all this spaghetti in the first place? Well, it often came from an older, more traditional way of coding called procedural programming. See, in the procedural world, you basically have 2 completely separate concepts. You've got your data, which is just sitting there in a bunch of variables, and then way over here, you have your functions, which are designed to operate on that data. They are totally disconnected, living in different parts of your codebase. And that's where object-oriented programming comes into the picture. It looked at that separation and said there has to be a better way. It introduced a totally new way of thinking. Instead of keeping data and functions apart, OOP decided to bring them together. And here it is. This is the fundamental shift. OOP takes related data and the functions that work on that data and bundles them into one single self-contained unit. And we call that unit an object. The variables inside are now called properties, and the functions are called methods. This simple idea, it really does change everything. Okay, so this leads us right into our first 2 pillars, which are all about how we structure these objects. It's all about bundling and hiding information. First up, we've got encapsulation. This is that core idea we were just talking about, the practice of grouping related data and its corresponding functions into one neat little package, one object. You can think of it like a recipe kit. It has all the ingredients and the instructions all in one box. Everything you need is right there together. Let me show you why this is so awesome in practice. So, the old procedural way, you might have a function called getWage. And to make it work, you have to pass in 3 separate pieces of data: the base salary, the overtime hours, and the rate. But with OOP, in our object-oriented way, the getWage method needs 0 inputs. Why? Because the base salary, overtime, and rate are already bundled right inside that employee object. The data it needs is already there with it. And this perfectly captures a famous saying from the legendary software engineer Uncle Bob Martin: the best functions are those with no parameters. The fewer things you have to juggle and pass into a function, the easier it is to use, and the harder it is to mess up. Encapsulation helps us get there naturally. So our second pillar is abstraction. Now, if encapsulation is about what we put inside the box, abstraction is all about what we show on the outside of the box. It's really the art of hiding all the messy, complicated details. I want you to think about an old DVD player. On the outside, what do you see? A super simple interface, right? You've got a play button, a stop button, an eject button. You know exactly what they do, and you don't need a user manual to figure it out. It's simple. But if you were to pop the HUD on that thing, it's a whole different story. Inside, there's a world of complexity: lasers, motors, logic boards doing all sorts of crazy stuff. All of that is hidden from you because, well, you don't need to know how the laser reads the disc to watch a movie. That's abstraction. We hide the internal complexity and only show the essential controls. And this gives us 2 massive advantages. First, it just makes our code objects way easier to use. Simpler interfaces are always better. But second, and this is a huge one, it reduces the impact of change. Think about it. The engineers could completely redesign the guts of that DVD player, but as long as the play button does what you expect, who cares? Your experience doesn't change. It's the same with code. We can totally refactor how an object works on the inside without breaking all the other parts of the application that use it. All right, so we've bundled our code into these nice, clean objects, and we've hidden away all the messy details. Now we get to the really cool stuff, the pillars that give OOP its superpowers, reusing and reshaping our code. So, pillar number 3, inheritance. This is an incredibly powerful tool for getting rid of redundant code. Instead of writing the same stuff over and over again for objects that are kind of similar, we can create one generic or base object and then have other, more specific objects inherit all its properties and methods. You see this all the time with something like HTML elements. Think about it. A text box, a checkbox, and a drop-down menu are all pretty different, but they also share a lot of common features, right? They can all be hidden, they can all be disabled, and they can all be clicked. So instead of defining those common features on every single element, we can define them just once on a generic HTML object and let all the others inherit them automatically.
Yeah, at the end of the day, that's what inheritance is all about. It's the don't repeat yourself or DRY principle in action. It helps us write less code, which means our code is cleaner and a whole lot easier to manage. And that brings us to our fourth and final pillar. Now, this one's a big word, polymorphism. But don't let it scare you. If you just break down its Greek roots, it tells you exactly what it means. Poly means many, and morph means form. So polymorphism is just the ability of something to have many forms.
So what in the world does that actually mean when you're coding? Well, it lets us get rid of those horrible, messy if-else blocks or switch statements. For instance, imagine you need to draw several different elements on a screen. The old way might be a giant switch statement. If it's a text box, draw it this way. If it's a checkbox, draw it that way. Ugh. With polymorphism, we can just tell every single element, hey, render yourself. And the cool part is the text box object knows how to draw a text box, and the checkbox object knows how to draw a checkbox. It's one single command that results in many different correct behaviors. It's incredibly powerful. And there you have it. Those are the four big ideas, the pillars holding up the whole philosophy of object-oriented programming. Let's do a quick recap just to put it all together. So here's the payoff, the whole shebang. Encapsulation bundles our data and methods together to reduce complexity. Then abstraction comes in and hides that internal complexity, which isolates the impact of any future changes. Then we have inheritance, which helps us eliminate redundant code by promoting reuse. And finally, polymorphism lets us get rid of all those ugly conditional statements, making our code way more flexible. Together, they help us write code that isn't just clean, it's robust, it's maintainable, and it's scalable. And that wraps up our look at the four pillars of OOP. We've seen how these concepts all work together as a team to fight that dreaded spaghetti code and build some really powerful software. So that leaves me with a final thought for you. They all work together, for sure. But if you had to pick one, which of these pillars do you think is the most powerful, the biggest game changer in how we build things today? Something to think about.